All right, so we all know what the integers are. These are the numbers 1, 2, 3, etc., etc., etc. And we also know how to add integers. That is, combining two integers together to get a new integer. So for 1 plus 1 is equals to 2, for instance. Now, suppose I went into a different room and I relabeled all of the integers into something else. So instead of calling 1 1, I call it an apple. Instead of calling 2 2, I call it a chair or something like that. And suppose I came back into the room and I'm like, but when you have an apple and you have a chair, you combine them together, you get a fruit or something like that, or a bag or something like that, right? So this is a very confusing situation. You don't know exactly what I'm dealing with, right? But I'm dealing with the integers with addition. All I just did was relabel things around and had this operation of combining things together to get another thing or another object after that, right? So mathematicians have been interested with this idea of things being the same but different at the same time. This is called the idea of an isomorphism. When I was dealing with fruits and apples and all these things and putting them together and getting another object, it was very confusing. But if I'm dealing with integers and addition, it's very easy to understand, right? So this idea of isomorphism is very interesting to mathematicians. In particular, the research that has been done was like, okay, we have an algebraic structure, and from this algebraic structure, we're able to produce integers, which tells us what this structure is, right? So we look at these integers, and from these integers, we're able to tell that, oh, but this is the real numbers with addition. These are the fruits with that weird operation that I defined by just looking at these numbers. But the research that has been done has been only localized to a small subset of algebraic structures. From looking at those numbers, we're only able to tell that a few of these algebraic structures are certain kinds of structures which we know. So what my research focuses on is extending the information that we're able to get from these numbers. So instead of saying that these numbers only recognize these few algebraic structures, we're able to say that these numbers recognize a larger class of algebraic structures. Thank you.